Power to the truth. This is Margo. This is Wednesday, April 17th, 2019, 6 p.m. Pacific Time, United States of America. So we're going to look at some methane today. We got methane new data as of yesterday, or for yesterday. They've been putting it up pretty much on a daily basis once they got caught up. So there's data up from the Saturday the 13th, then the 14th, 15th, and the 16th. But we're going to look at the 16th for the Arctic view for surface level, and then we'll look at some other views too. Then we're going to look at Sam Carana's latest blog post about how much time we have left, and it's the worst report yet I've seen. And then we're going to do kind of a climate roundup. I'd like to look at climate Reanalyzer, go over that, peek at Arctic sea ice, and then do earthquakes. So it's going to be a jam-packed show, so sit back. So I already have the movie loaded up for the Arctic here. So this is where it was at the starting on Tuesday. There was a release from Novaya Zemlya, or in the Kara Sea, and then when it goes into the forecast period, we're seeing this huge release come up from the European area, and it's actually coming up. This is surface level, remember, and we'll look at the Europe view and get a really good and up close look at that. So it's coming up from the Atlantic Ocean, coming up beside Iceland before it kind of fizzles out there. That wave, all these methane things are releasing in waves. So the data is from Tuesday, and then the forecast goes through Saturday. And their forecasts are pretty accurate. We're seeing a high release up here, right here in Russia, where Russia and China kind of meet. And of course China has a high release. We're still seeing building and releasing in Siberia over here. But overall, the Arctic itself looks pretty quiet compared to what we have been seeing about a month ago, except for this now is happening down here out of Europe. Canada, most of Canada looks pretty quiet. Greenland is quiet, and North America has its issues. So we're going to take a peek at some of these others here tonight. And so we'll get caught up on methane. So I'm going to load up another view now. Let's load up the Europe view. And so what we see here is this is it's kind of hard to see the countries because they're all covered up with methane. This is the UK, this is Ireland, this is France, and this is I'm not sure of all these little countries, Belgium and Netherlands over here, and then it spreads on over. And then Norway is picking back up, and so let's load this movie up. And see the wave. Look at all that black. And it kind of comes and goes because when the sun goes down, it gets less, and then when the sun comes up over there and it heats everything up, it becomes more. Okay, now it's loaded up and smoothed out. So here it was at the beginning of today, Wednesday the 17th, with all of this area pretty dark brown. I call it black. And look at the stream moving up in the Atlantic Ocean. That's just not looking good at all. I'm kind of flipping out over this. And here's Portugal over here. It's got its issues. And then the northern part of Spain. The Mediterranean is pretty high on this northern coast of Africa and in the Mediterranean there. And over here in on the east side of Africa and Saudi Arabia. Okay, so let's leave that. Now let's pull up the North American view. See what's going on over here. And then we'll get a global view. And then we'll have a pretty good understanding of where methane is at right now. So here it is at the beginning of Tuesday, yesterday. We're seeing this release through the Mississippi Valley and coming on up, and this is where all that flooding had happened. And so as we load this movie up, we'll see these rates of release kind of fluctuating. As I said, when the sun comes up and moves across, you know, everything starts heating up. Then we've got this high wave. See the wave just moving across into the Atlantic. Remember, in the old scale on cams, before they changed it, they changed this color ledger in December of last year. All this green was this orangey color. So now see, a lot of the western US goes into the blue color because it gets cooler. It's a little cooler over there now as it's going into the forecast period. Okay, here it goes. We got some high releases up here in Canada. Now this is where the Rocky Mountains extend up into Canada. It's high around Seattle and Vancouver, and then coming down through California, through the middle of California and Southern California. Although it's looked worse than that. That's not the worst I've seen, but it's still pretty high. Then southern Florida. So, like I said, this is not the worst we've seen it, but it's definitely, look at that wave going out. Things are definitely heating up. And now it's mid-April, so we should be starting to heat up a little bit. But not as much as Sam Carana says we're going to heat up. You'll see. You'll see. You'll be flipping out when we read that report. Okay, here's the global view. This is from yesterday. So we can see if we can load this up. Sometimes it takes a little while for everything to go, but it's cooperating. So here's that release out of Europe that we saw. Here's Norway and these areas here. Here's Novaya Zemlya and coming up out of the Kara Sea. Here's China. Here's northern India. And Australia looks pretty good. You really have to zoom into that area to see it. But they have releases on this eastern coast, and New Zealand has pretty high releases too. South America in the interior has high releases as well. Okay, so let's move on. So we'll leave this in the background. And now I've pulled up, this is arcticnews.blogspot.com. This is Sam Carana's blog. This is his latest post. It's from today, Wednesday, April 17th, and it's entitled, How Long Do We Have? Everybody asks that. Everybody is saying, are we there yet? Are we there yet? And it's like, no, we're still here, so we're not there. So he says, he addresses, how long do we have? Again, the March 2019 temperature is in line with an earlier analysis that 2019 could be 1.85 degrees Celsius warmer than pre-industrial, and that a rapid temperature rise could take place soon, as illustrated by the image below. How long do we have? Oh, it's a little easier to read from the article. It's bigger over there. He says, a trend focusing on short-term events shows how a 3 degree C rise from pre-industrial could be reached as early as in 2020. Well, we're well into 2019, so 2020 is only 8 months away, while a long-term trend points at the year 2025. So here, here the red line goes straight up. A catastrophe of unimaginable proportions is unfolding. Life is disappearing from Earth, and all life could be gone within a decade. At 5 degrees C of warming, most life on Earth will have disappeared. When looking at near-term human extinction, 3 degrees C will likely suffice. Study after study is showing the size of the threat, yet many people seem out to hide what we're facing. Created by Sam Carana for ArcticNewsBlogspot.com with NASA low-T data adjusted 0.78 degrees Celsius to reflect 1750 baseline, ocean air temperature, and higher polar anomaly. Trends are added based on 1880 to 2019 purple and 2000 to 2019 data red. So it's not looking good. So here are the years starting in 2010. This is where everything was at 2010 at 1.5 degrees temperature rise from the 1750 in Celsius. So it was, by 2010 it was 1.5 degrees Celsius above it. And then it went down for a couple of years, and then it started coming up, and then it went down a little bit, and now, okay, so here was 2018, and then here's 2019. So we're in 2019, and so 2020 is this next line. So we are here on this dot, here about on this dot, which, I didn't mean to do that, being April. So here's 2 degrees. So by 2020, he's thinking it's going to be here. It looks like 2020, it looks like we could reach 2C before 2020 according to this chart. It shows 3C from in 2020. So while we're in 2020, he's saying it could shoot up to 3C in 2020. Okay. A catastrophe of unimaginable proportion. Oh, I've already read that. That was in that paragraph. Above image asks, how long do we have? The image is created with NASA LODI data, adjusted 0.78 degrees Celsius to reflect a 1750 baseline ocean air temperature and higher polar anomaly. Trends are added based on 1880 to 2019, that's in the purple, and 2000 to 2019 data in the red. The long-term purple trend points at 2025 as the year when 3 degrees C rise from pre-industrial could be crossed, while the red trend that focuses on short-term events shows how 3 degrees C rise from pre-industrial could be reached as early as in 2020. Oh, we're toast if that happens. The chart below shows elements contributing to the warming, adding up to a rise of as much as 18 degrees Celsius. That's by 2026, 18 degrees Celsius. So, here we are. Here's 2019 at 1.85 degrees. Here's 2020 at 2 degrees. Here's 2021 at almost 3 degrees. Here's 2022 at close to 4 degrees. 2023 close to 5 degrees. 2024 over 6. 2025 close to 7. And 2028, he's saying anywhere, 2026 could be 18 up to 18 degrees. And that gray area, he's figuring in clouds feedback, because we're gonna have so much moisture in the atmosphere, with it being that much hotter, then all the clouds would do a bunch of feedbacks too. So we'll be a Venus-like planet, hot. The situation is dire and calls for comprehensive and effective action as described at the climate plan. So, there's Sam Carana's latest. So I'll leave the link below, and you can take a look at that. Now let's take a peek through. Let's take a trip through Climate Reanalyzer. Here's the temperatures from today. Here's maximum, and here we are on the globe. So it's cooler up in the Arctic. That's probably why we're not seeing a lot of methane coming out, but it's definitely warm around the equator regions, and then cool of course in the Antarctic, and it's turning winter down there. Now when we look at our 2-meter temperature anomaly, Greenland is in the brown, a lot of Greenland, and it's brown coming across Svalbard and over to Novaya Zemlya. And this is the air that's higher, meaning it's higher than normal. So in the brown, that's about 10 degrees Celsius higher than normal. And then when you get up into the red, that's 20. And up into the light pink is 30. So we can see Canada is in the brown. Parts of the United States are in the brown. But when we look at Europe, it's just, it's not that brown, considering like Greenland and everything. So it is kind of tannish color, but it's not extremely high in temperature anomaly. So that would not explain that high methane release that we're seeing. But we're seeing brown over here in Siberia, and over here in Tibetan plateau, and over here in China, and here in Russia, or China and Russia over here. And then Australia definitely has brown going through it. Northwest Africa and southern South America. And then the Antarctic is a little easier to view from the global, is definitely in the brown. So, and parts are in the red, and so with that, then it's going to be hard for that sea ice to come back. Then, if we look at our precipitation, okay, United States, we've got rain up in the mid upper part of the country, and snow over here, and snow through the Rockies. And then the system, here's the system that we just had, and it's moving across the Atlantic, and it's headed towards the UK. Now, and it's headed, and then this other system is also headed towards Europe and the UK. And we've got this band all around the equator. Here's a system off the coast of South America. And then here's Australia that's completely dry, and New Zealand that's completely dry. They're still in their drought, but there's rain all around it. Makes you wonder. Now, let's look at the jet stream. Oh, jet stream. Here we go. Here's our loopy-loop, crazy. Look at this going down and around. And then it splits off and goes across Africa. And then it loops here and there and here and there. That's crazy. But this is what's happening. As in, look at this, looping across the Pacific and another loop down south. But this is what's happening with the abrupt climate change, and the cooling is off and everything is off. So here's what it looks like on the flat view. So because of this, it's going to be hard to grow any grains, to grow anything, to grow any food. The farmers aren't going to be able to plant where they had all that flooding. That flooding covered lots and lots of states. I mean, this whole area. And that's where most of the farming takes place is in where it flooded. Here's the sea ice as we go around. So we can see it's starting to come back around the Antarctic now. And then sea surface temperature anomaly. And look, this is from yesterday. They're always late updating. They're always a day late at least on sea surface temperature anomaly. I don't know why. It's just like CAMS being late on methane and carbon dioxide. So we're seeing very high sea surface temperatures on the east coast of the United States and moving out into the Atlantic, and then in the brown color here, red along here, brown at the tip of Greenland, and brown as it goes up by Iceland, and then brown up here by Svalbard, and brown by Novaya Zemlya. Now this is where we're seeing the methane come up, and the sea surface temperature is in the brownish color, so like 1 to 2 degrees higher than normal. And the Mediterranean is brown. Most of the places where you see water is brown or red. Look up here by Alaska. That's red and brown. That's when the water's coming up into the Bering Strait. It's red by South America. And here's the Tasman Sea between Australia and New Zealand, and it's red and brown. And that's been like that ever since all summer for them, and now they're heading into fall. So let's leave that, and now I have NASA Worldview pulled up for today, April 17th, and we're looking at the Arctic view. So I thought we'd just take a tour of the sea ice and see what's going on. Here's Greenland, and here's the ice in the Baffin Bay, and there are not many clouds here today, so we can get a really good view of what the ice is doing, and it's breaking up fast. It's melting and breaking up real fast, it looks like. And it looks like it's melted on this western side of Greenland, pretty much. Looks like these are weird looking clouds. Anyway, but here's the ice. I remember last year when we were seeing it melting around this northern edge, and all the climate scientists were all up in arms because they said it was going to be hard for the sea ice to refreeze up here. And we can see in these little tributaries it's already melting. We can see that is not solid at all. That is just not solid. Now we might be looking through a little bit of a cloud cover here, but you can see the chunks of the ice, and then there's the ocean underneath. So here's Greenland. So this ice is already breaking up and melting. And it's way too early for that. Look at that. It's just way too early for that. Now here's the edge, the eastern side. These are clouds over here. Ooh, look at these weird clouds. V-shaped. You never know what you're going to see on NASA Worldview. I'm not going to say anything. But you know what I'm thinking. It looks pretty interesting in the clouds up there. But I'm not going to say anything because I don't want to come under attack, because this is going to be a public video. But you can just see all of these interesting things in the clouds and make up your own mind. Here's Svalbard, where the seed vault is. Seed vault right here. Look, no ice. See? No ice. No ice. Here's a little skim. That's not very thick. That's just barely there. That'll be gone quickly. Here's Novaya Zemlya. Now this is mainly cloud covered. Let's go back a day. That's easier to see. So we can see there's no ice around this western edge, and then, or on the southern end, and it's come away from a lot of the island here, and it never refroze really good. And they were running that icebreaker through here too. You can see where they were running the icebreaker through on the Yamal Peninsula. Oh, here it is. See? You can see where they were. There's the channel where they were running that icebreaker through to that gas production thing. So, it's coming apart fast. Look at this. You can see lots of blue ocean there. That's from yesterday. It's easier to see here with no clouds. Lots of blue ocean. Getting lost. Where are we? Okay, here's the Chukchi Sea. Here's this East Siberia ice shelf. So we're keeping an eye on this because that's where all those methane reserves are. Well, they're all over the place, but there's a whole bunch over here. So we're coming back to today. We got a better view here. So we can see the separation is even more here. See? And this ice is really breaking up fast. Here's the Bering Strait. That's pretty cloud covered. It's hard to see. Here's some ripple clouds. Look at those. I'm not going to say anything. I'm just going to zoom in so everybody can see them. Make up your own mind. What's going on up there? Look at this coastline, how far away the ice is from the coastline there. This is Alaska. See, it's melted on up further. Here's Wainwright for our friend from Wainwright. It's around in this area. So that ice is melted up. Melted, broken up. You can definitely see. Look at those clouds. Here's Barrow. This is at the very northern part. Here's the Beaufort Sea. And we can see it's melted over here by Canada. See that? Large areas. This is the Amundsen Gulf. Look at that. That's all broken up. Large areas of no ice. And this is what ice is there is very thin right here. And then we're back around. These are Canadian islands. Oh, didn't mean to do that. And this, along in here is where that thickest ice used to be, all along here and out. But we're seeing that it's not like that now. See, it's already broken up and melting. So it's going to be a hot summer. So fasten your seat belts. It's going to be a hot summer. Just expect more and more severe weather, more and more catastrophic things, and large mesoscale systems. Those are systems that cover big areas. You can see that's broken up already. That's through the clouds there. And here's the North Pole. Alright, I've had enough of that. So there is our tour of the Arctic sea ice for today. Now let's move on to earthquakes. Get this done. We're looking at USGS. Oh, I forgot to pull up my tremors map. Hold on. I'm going to pause the recording. I'll be right back. Okay, I'm back. So we're looking at USGS for the last 24 hours, all magnitudes, and we're showing 276 worldwide. So that's gone way down. since yesterday. What was it, 350 or something yesterday? That's gone. The number of earthquakes has gone way down. Of those, 27 are 2.5 magnitude or higher. So let's see what's about to come off the map, and we'll start there. Here's a 3.6 in Dominican Republic at 6:43. Okay, so let's start in the Dominican Republic. I've got all magnitudes pulled up here, and we're showing 10 here today. We'll call them off. 3.5, which was this 3.6. Sometimes they list them a little differently. This one happened at 6:43 last night, Pacific time, 136 kilometers deep. Now all the times I'm going to be telling you are Pacific, because that's my time zone. Now this happened on land right here, so that's not big enough to really cause damage, but you could probably feel it if you were close enough to it. Except it was pretty deep, and the deeper it is, the less you feel it on the surface. So, but that probably didn't cause any damage. But it's showing movement. 1.4, 2.2, 3.2, 2.5, 2.8, 3.1, 2.6, 3.1, and 1.7. So there's that. Now, let's move on over to this area. We're going to start here with this Panama Basin, this 5.1 that happened south of Panama, right on the red line, tectonic plate line, at 2:55 this morning. Now the Panama Canal, in case people don't know about it, is right here, right along here. And that connects the Pacific Ocean with the Atlantic Ocean so that the ships can take a shortcut through there instead of having to go all the way around South America. So that's pretty close. That's getting close, and that's a 5.1. That's a pretty good sized earthquake. Next is a 4.4 off the coast of Salinas, Ecuador at 2:13 this morning. Next was a 4.9 near La Peca, Peru at 8:01 this morning, 46 kilometers deep. And that's all over here. Now moving across the Pacific, we had 3 here yesterday at L'Esperance Rock, or near there, L'Esperance Rock, New Zealand. And here's another one, a 5.0 that came in last night at 10:03 p.m., 330 kilometers deep. So the deeper they are, the more they will cause the tectonic plates to move across the planet. Uh-oh, what do we have here? This is Papua New Guinea, all at the same place. And we've got 6 here. It started at 1:21 this morning. 4.9. And then another 4.9. 4.9. 4.9. 5.2. And 4.6. This last one happened at 4:50 this afternoon. Now this has the little wave on it, meaning possible tsunami. So let's click on that and we'll see if there are any tsunami reports for that. No, there's nothing for today listed here. The last one was British Virgin Islands in Puerto Rico. So there was no tsunami warning for that we know of. So those all happened in the same place. This 5.2 happened, looks like on land, best I could tell. So that could have caused damage. Or it might have happened right in that little inlet. So that could cause definitely structural damage if anything was nearby. Then a 4.3 near Samlaki, Indonesia at 6:36 this morning, 167 kilometers deep. Next, 4.5 near Namuac, Philippines at 7:19 last night, 50 kilometers deep. Next, off the coast of Hokkaido, Japan, 4.5 near Nimuro at 2:07 this afternoon, 36 kilometers deep. Now, let's see what happened on land. 4.2 near Ashkasham, Afghanistan at 11:35 this morning, 147 kilometers deep. I think that's it for over here. Okay, that's all for the international earthquakes. So, let's go to Hawaii now. We've got 9 here today. So I'll call them off. 1.6, Waikoloa Village at 8:33 last night. 1.8, that's at Kilauea Volcano, 9:53 last night, 0.2 kilometers deep. 2.1 Kilauea, 4:41 this morning, 0.1 kilometers deep. 2.4 Kilauea at 5:04 this morning, 0.1 kilometers deep. 2.4 Kilauea at 5:05 this morning at a minus 0.3 kilometers deep, meaning that was up in the crater, up on the side, the magma, all the movements going up there. 1.9 Kilauea at 2:10 this afternoon, 0.4 kilometers deep. 2.0 Pahala, that was in the ocean, at 2:45 this afternoon. 1.8 Pahala at 2:47 this afternoon, and a 2.1 near Volcano, Hawaii at 5:34 this afternoon. So these two down here were in the ocean. All these here, Kilauea, looks like 3 were in the crater. This one was kind of on the rim, and these were on the side. So that's still moving, so we got to keep an eye on that. Next, we're going to move up to Alaska. Here we're showing 91 here today of all magnitudes. Alaska averages between 50 and 100 a day. because they're very earthquake prone. They have a lot of volcanoes up here too. At Kobuk, they've got 3 that are 2.5 magnitude or higher. They had a 2.8, 3.5, and 3.8. And everything else in Alaska was under 2.5 magnitude. So, a lot of little quakes. So, Kobuk had 32 here today. A lot of them at surface level. When you see 0 kilometers depth, that means they're at surface level. So most of them were like mid ones to upper ones. Here's a 2.4 at surface level. So that's still shaking. Whatever's going on up there, I don't know. I don't know what's happening. And here's a 1.6 Arctic Village, 2.0 Arctic Village. Both of those are at 0 kilometers depth. 2.1 and a 2.0, 2 at the same place. These are all at surface level for whatever reason. That's just pretty bizarre to me. And now they're peppering down, they're spreading out through the center of the state, it looks like. Spreading out, coming down. Here's the Alaska Range. Here's Anchorage. In the map here today, we've got 32. They're clustering down here in this Anchorage area. They're small, but small ones can lead to larger ones. And the volcano chain goes right down here, right along the edge of the water, and then it turns into the Aleutian Islands, and all those little islands are volcanic. Now let's come on down into the lower 48. Oh boy, that looks eerily quiet. That's pretty spooky to see it that quiet over here from the middle to the all the way to the east. We've got 2 in Utah, a 0.9 at Salt Lake City, and a 1.3 near Farron. And Yellowstone is only showing 1 today, a 0.1 near Whitehall, Montana, at 7:04 last night. Now, in the Pacific Northwest, we've got a few here. Let's look at the real-time tremor map. So in the last 3 hours, this is what the tremors look like. Mainly up here in the Seattle area. 1.2 hours of tremors in the last 3 hours. In the last 24 hours, the whole bunch. So they're all clustering up here in the Seattle area. And that's, oh my gosh, 9.2 hours of tremors in the last 24 hours. The highest I've ever seen it was like 8.2. That was a few days ago. But they weren't there. They were further down. 9.2 hours of tremors in the Seattle area in the last 24 hours. Let's look at the last 48 hours. 11.2 hours of tremors in the last 48 hours. So the majority of them have happened in the last 24 hours. It's all right up here. 9.2. Alright, here we go. 1.1 Vancouver, Washington, right down here. 1.2 Topanesh, Washington. 0.4 near Intiot, Washington. 1.1 magnitude from an explosion near Louisville, Washington. This happened at 12 noon at a minus 1.2 kilometer depth. And then another explosion of 1.1 magnitude near Napavine, Washington at 1:30 this afternoon at a minus 1.1 kilometer depth. Here's Mount St. Helens, the big volcano. So we had an explosion to the northwest of it and to the southwest of it. Makes you wonder. It just makes you wonder. Here in Northern California, 2.1 near Cape Vizcaino at 10:36 this morning. Here in Northern Nevada, a 2.2, they're calling it near Lakeview, Oregon. That was the reporting station, but it was actually in Nevada. This happened at 10:26 last night. Now in the Reno area, we've got a 1.1 near Truckee, 0.1 near, that's in the Mount Rose hiking area, 0.2 down outside of Carson City. Here's another explosion, 1.7 magnitude explosion near Lovelock. .37 this morning. 11 kilometers deep. Are you kidding me? They're blowing up stuff underground. They're tunneling, I would imagine, with it that deep. Here's Lovelock, and that was in these mountains to the east of Lovelock. Now the Lovelock Cave, where they found the giant skeleton, is back here. You go here, and then you get on this dirt road, and you go a long way, and up in the mountains, in the foothills, there was a cave that they call the Lovelock Cave, where they found the skeleton of like a 13-foot red-haired giant in there, and the Paiute Indians smoked out the giants and killed them. It's a whole story. I've been there. I got pictures somewhere. Anyway, if I find them, I'll scan them in and show them to you. That was before I got my digital camera, or before my digital camera was given to me. It was a gift from my best friend. Said, "You take pictures all the time. You need a better camera." So now I take pictures with that. Here's a 1.3 near Yerington, And then here's some down in the Hawthorne area. Uh-oh, we've got a cluster here. Just 2. It's 2 a cluster. 2.2 is the highest one there. We've got quite a few down here in Hawthorne today. Then here's 1.3 near Austin. Here's another explosion, a 1.5 magnitude earthquake from an explosion near Tonopah. That was at the surface, 0 depth. And then here's some little earthquakes down in southern Nevada where the Nevada test site and Area 51 are. That's where those are. Nope, went too far out. So, that looks pretty clustered today. So we made up for the east side being empty. So let's look at California on this east side. Here's one near Mono Lake, a 1.4. Now, let's look at Mammoth Lakes. We've got 19 here today. 19. 1.8. That's one of the higher ones. Here's a 1.4. 19. This is in that Long Valley Caldera area, which is a super volcano. But it looks like they mainly clustered here around 395, this highway 395. Then here was a 2.5 near Wilkerson. Then, coming on down, here's a 1.0 near Olanche. Here in the Coso Junction area, we've got 5 today, 2.1 being the largest, at a minus 0.3 kilometer depth, meaning the earthquake is up in the mountain. That came in last night at 8:32 p.m. .1 Coso Junction. Here's a 1.1 Tacoma. Now we're coming into Southern California. Here's a 1.7 Johannesburg. Here's a quarry blast, a 1.6 magnitude quarry blast near Boren. And a 1.4 quarry blast near Tehachapi. Here's a 1.8 Tehachapi. 1.3 Nenoch. So, in Southern California, today, we've got, let's see if we can get, here's another quarry blast at 0.9 near Lubbock. We saw that. We saw those. So Southern California, let me get them on the map here. I'm not going to count, I'm going to count all those. Has 43 today. including the quarry blasts and explosions. So that's a little higher number. Here's one that just came in, a 1.5 near Pine Mountain Club. That's on the San Andreas fault line, this red line. So these are pretty small, but they're clustering. Here's Kauai and so forth. And small ones can lead to larger ones, remember. A lot of times they do. Saw that. Okay, let's come up the San Andreas fault line. See what's going on. 0.8 Pinnacles, 1.0 Ridge Mark, 0.7 Gilroy. Saw that. We got two here. A 2.8 San Juan Bautista and a 1.6 same place. 2.8, that's getting on up there. Then a 2.2 near Cupertino. Here's one to the west of San Francisco in the water, a 2.0 near Colma. Okay, we saw that. Cupertino. Now the geysers. Here's one off to the side, a 1.8 near Hidden Valley Lake. Including that one, we've got 39 here today. So 38 right here at the geysers. Most of them are ones or under. Here's a 2.5 at the geysers. And that's it. Oh, that's not it. Here's a... Oh, we saw the Cape Vizcaino. We didn't do this one. A 2.7. This is on this Juan de Fuca plate. This is the Juan de Fuca plate, and this is the where where the Pacific plate meets with it. 2.7 that happened today at 2:57 p.m. So let's zoom out and see if anything came in while we were doing all that. Here's a 3.8 at Kobuk. That just happened at 6:35 p.m. 36 kilometers deep. Oh, look, and a 3.5 at Kobuk. 3.5 happened at 6:34, and then a 3.8 happened at 6:35, all tonight. We saw all these at Papua New Guinea. So I think that's a wrap. So time is so short. It is so short. I wish I knew, but I don't know, and no one knows the day or the hour. So I recommend you get your spiritual houses in order right now, especially considering Sam Carana's report and considering what we saw at the sea ice today. So everyone take care. God bless. Go in peace and goodbye.